Welcome to Study Loop.
Hi. So in this problem, it is given that there's an electrical wire that is hung between two insulators. So let these be the two insulators, and there's an electrical wire hanging between the two insulators. It is given that it has a sag. Sag means this thing, the bending shape of the cable. So this is the sag, and this distance is sag, and this is given to be 1.5 meters. It is also given that the mass per unit length of the cable is zero point 0.6 kilogram per meters, and it is also given that these two insulators are 60 meter apart. So what is being asked in part A? It is asked to calculate the maximum tension in the cable, and in part B it is asked to get the total length of the cable, the length of this complete path. So that's denoted by S. So we have to find this too. So let's say that this sag of we denote this sag by H, 1.5 meters. Okay, well, now let's solve this problem. We know that the weight is nothing but mass times the acceleration due to gravity. So instead of this mass per unit length, we can also get the weight per unit length. Let's denote it by W, small w, and it should be equal to mass per unit length zero point 0.6 kilogram per meters multiplied by 9.81, the acceleration due to gravity, and this is the units of this is in Newton per meters. So we'll use all of this as it is in the we're not solving it right now. We will just put this thing in the equations. So whenever we are given a cable like this, we first draw the x and y coordinates, and we make the origin to be the lowest point of the cable. So this is x and this is y. This point, the origin 0 0. Okay, and we consider that the tension in the lowest part of the cable is T naught. And from our book we have a formula that this tension in the lowest part of the cable T naught is equal to W x square over 2y. So let me tell you from where this formula comes. This comes from the fact that y is equal to W x square by 2T naught. We just rearrange terms and we get this. So this thing here is the equation of a parabola. We can see that the shape of the our cable is a parabola, and that's why it relates the y or the or this thing, this height, and x is the distance from this origin, and y is this height. Okay, so we have this formula now. and from this we get T naught. T naught is equal to W is the same, the weight per unit length here, and we just put it here, 0.6 multiplied by 9.81 Newton per meter, multiplied by, so this X and Y here, it is true for all the points on this cable. So because we know the length of the insulator here or here, we we can just we can just use use this equation for at this point. So, at this point we are writing the value of T naught. So T naught 0.6 into 81, and we can see that this point here is x part of it is 30, 60 by 2. 60 divided by 2, 30 is the x coordinate of this point, 30 is x, and y here is 1.5, because if this thing here is origin, this y would be 1.5. Okay, now let's put w into x squared, that is 30. X squared, w into x squared into 30 square divided by 2 times y at this point, 2 times 1.5. So solving this, we get T naught equal to, solving this equation, we get T naught equal to 1764 Newton, or we can write it as 1.764 kilonewton. Okay. Okay, now we know that if these two are the insulators and if this is the cable, then the maximum tension would be here, and this is the tension in the horizontal direction, this is the maximum tension in this part of the cable, and there is one more component, the weight of the cable that is acting downwards, that's denoted by capital W, and this capital W is weight in newtons, and we know that we have the weight per unit length as small w. If we multiply it by length of the cable, and this is at every point, so we are again taking the same point, the second insulator. So this W times L should be the weight of the cable in weight of this part of the cable in Newton. So that is W times L. So that is L is 30, and our small w was zero point 0.6 times 9.81. Okay, and this gives a value of around 176.4 newtons. Let me calculate this and be sure of it. Yes, around 176.5 newtons. So the maximum tension in the cable would be the resultant of this. So this is the weight, and to counteract the weight, there is a force acting here, which is the tension. So the resultant is the maximum tension, the resultant of the horizontal tension, and this weight There is this weight is equal to 176.5 Newton, and this we know as it will be equal to around 1764 Newton, and resultant of this is here. This is the maximum tension, and it can be calculated using the Pythagoras theorem, because this is the hypotenuse. So if T naught is here and W is here, so this is the hypotenuse of the two, and this is equal to under root of this capital W square plus T naught square, and this will be equal to under root of 1764 square plus 176.5 square, and this maximum tension would come to be equal to 1775 Newton. So this is the solution of the first part. The maximum tension is 1775 newtons. Okay. So in the second part we want to calculate the length of the cable. So this was our cable between 2 points, and this was the length of the cable. So we want to find the complete length of this path. This is S. So if this is our origin, we can find the length of any portion of the cable. So first we are trying to find the length of half of the cable, and due to the symmetry it will be equal to the half of the length of the total cable. So so let this be equal to S1, and we will know that this complete S would be equal to, so S would be equal to twice of S1. Okay. So we have a formula to get the S1, that is equal to X times, X means the coordinate of any point from the origin. So X here, if we are taking that this part as X, so X here is 30. So let me write the formula first. S plus 2 over 3 y over x. So y is the coordinate of this point. So y is 1.5, x is 30. Minus 2 over 5 over y over x times 4. So this will have more terms, this equation, because it's a binomial expansion. But we will consider only two terms, because it will converge only in two terms, or maybe I think it will converge only in the first term. So S1, if you substitute the values of x and y, S1 is 30 times 1 plus 2 over 3, 1.5, and this is square, over 30 whole square, minus 2 over 5, 1.5 times, let me separate this. Let me write it again, this part. Just writing it again. So here, it's a S1 is equal to 30 times 1 plus 2 over 3, 1.5 over 30 square, minus 2 by 1.5 over 30 times 4, and this is equal to 30 times 1 plus 2 over 3, and this is around 1 over 20 square, and minus 2 by 5, 1 over 20 times 4. And we can see that this term is very small. We can just neglect this term, and this is 30 times 1 plus 2 over 3 times 1 over 20 times 1 over 20, We solve for this, and this comes to be equal to 30.05 meters. Yes, and the S is twice of this. So S, the total length of the cable is twice of this. Twice of S1 is equal to twice of 30.05, and this is around 60.1 meter. This is the solution of our part 2. Part B solution, and this was the solution of part A. Maximum tension equal to 1775 Newton. I think that's it. Thank you very much for following.